All right, so we're about to start naming organic compounds now. In this class, the only kind of organic compounds we name are real simple ones. They're called hydrocarbons, and they're called, in fact, all the ones we do in this class are straight chain hydrocarbons is what they're called. But I gave you this little quick review here about formulas that we've done so far. If the formula is a combination of only nonmetals, the compound is probably covalent, except if the compound has a hydrogen in the front of the formula or the word acid in the name, the compound is acidic. Okay? If the formula is a combination of metals and nonmetals, or if the formula contains a polyatomic ion, the compound is probably ionic, except if the compound has a hydrogen in the front of the formula or the word acid in the name, the compound is an acid. Okay? That's kind of where we are right now. All right? All right, now, organic compounds then. Organic compounds are typically made of all nonmetals, just like the non-organic compounds. But they, as a rule, have at least, that's not least, is it? At least 2 carbon atoms bonded together. Okay, and where do we get this word organic? It comes from living things. Okay, so this is the chemistry of living things. At least that's what it was originally. It's actually become a lot more than that now. But even the things that are really much more complex, like making pharmaceuticals. Okay, if you have to go to the doctor, they give you a prescription. You go to the pharmacy. That's a pharmaceutical. All right, those are organic compounds. But they may not have started with organic stuff at all. It's possible to make them out of stuff that's not organic. But originally it was all from organic stuff. Most of the organic stuff we get comes from crude oil. Okay, you start out with crude oil and you make plastics. Okay, so a lot of you are wearing synthetic clothing made of oil. Okay, the seat you're sitting in is made of plastic. Mostly comes from oil. Okay, so when we run out of oil, and it's a finite resource, eventually we've got to run out of oil, we're going to have to make plastics from something else. We are already learning how to make plastics from food stock, that is to say plants. Okay, but it's a more complex process. It'll take some time for the technology to catch up. Okay, so with organic compounds, you have metals bonded to, you have nonmetals bonded to nonmetals. In particular, you have to have at least 2 carbons bonded together. There's a few exceptions to that. But we are only going to be naming the straight chain hydrocarbons. We are only going to be naming in this class the straight chain hydrocarbons. The straight chain hydrocarbons. We are only going to be naming the straight chain hydrocarbons. Good. Okay. Need to write that down. All right. Straight chain hydrocarbons. That's all you have to do in a CP chemistry class. Straight chain hydrocarbons. And they're all named for the number of carbons in the chain. So all of them are named for the number of carbon atoms in the chain. And we have to learn some new prefixes. Okay, so these prefixes are, you have to memorize them, I'm sorry, You got some prefixes to memorize. The prefix for 1, when we're talking about organic compounds, is meth. Meth. The prefix for 2, eth. Prefix for 3, prop. For 4, bute. The prefix for 5, and don't pronounce it the way it looks, it's bute, okay? For 5 is pent. 6 is hex. Oh, there's that thing the witches do, right? 7, hept. 8, non. 8, I'm sorry, 8 is oct. 9 is non. 10 is dec. And you notice these look a lot like the prefixes we learned for the non-organic compounds after number 4. Only there's no A on these, okay? So pent instead of penta, hex instead of hexa, and so forth. That makes sense? All right. So in the last unit, we learned how to take electron dot formulas and figure out Lewis dot formulas. Remember that? I want to review that for just a minute. So if I have a single carbon, now this is the exception to our rule where we have to have at least 2 carbon atoms bonded together. There is one very important organic compound that only has 1 carbon in it. Okay, and this is the one I'm going to show you. How many electron dots around a carbon? 4. And we're going to put it together with hydrogens. How many electron dots around a hydrogen? 1. And so we're going to share electrons to give each of the hydrogens 2 electrons, because that's what it takes for it to be full, to have the same electron structure as a noble gas, helium. We want to get carbon to have the same electron structure as its next highest noble gas, neon, and so it wants to have 8 electrons. And by sharing electrons in this manner, we get the carbon up to 8 electrons and the hydrogens, all the hydrogens up to 2. Then we're going to squeeze the electrons together in between the symbols for the atoms, and we have what we've called a Lewis dot formula. Remember that? Okay, that was a lot of what we did then in the last unit. I want to introduce you now to a slightly different version of this. Okay? Anytime you have a pair of electrons shared between 2 atoms, we can replace it with a single line. Anytime you have a pair of electrons shared between 2 atoms, you can replace it with a single line. What if I have 2 pairs? 2 lines. What if I have 3 pairs? 3 lines. Okay? So this then becomes got that? And this is the prefix that means 1 carbon is meth. If there are only single bonds between carbons, and this one doesn't have any bonds between carbons, the suffix is ane. So this is methane. Now, there's a condensation of this formula, simplification of this formula, and it's this. It also happens to be the molecular formula in the case of methane. Okay, so this is both the condensed structural formula and the molecular formula for methane. Okay. Okay, now this is called, this drawing here, where I had the Lewis, took Lewis dots and made this. This is no longer a Lewis dot formula. It's simply called a Lewis formula. Okay? And in terms of organic compounds, this is called the complete structural formula. Got that? All right. If I want to put two carbons together, I'm going to call it F. And if I have a single bond between the carbons, it's called F-ane. Okay? A-N-E. The A-N-E suffix means all single bonds. All right? So let's see. Two carbons, hydrogens, share electrons to get the hydrogens up to 2 electrons and the carbons up to 8, and you get this. Okay? And then you get this. For the Lewis dot formula, then we get a Lewis formula that is the complete structural formula. And we condense this into groupings of carbons and hydrogens. Okay? Condensed structural formulas. This is this complete structural formula. It is a Lewis formula. Okay, so we're doing ethane here. Okay, this is called the complete structural formula. Okay, and in the condensed structural formula, simply takes the groupings of hydrogens, okay, and groupings of carbons and hydrogens. Here's a grouping of carbons and hydrogens. How many carbons in this grouping are here? How many carbons in this grouping right here? 1. How many hydrogens in this grouping? How many groupings in this of carbons in this grouping? 1. How many hydrogens? 3. So this is going to be called, it'll be written like this. So this is a condensed structural formula for ethane. Does that make sense? All right, I want you to do everything for propane right now. Okay? Well, eventually we're going to be starting with Lewis formula, which is the complete structural formula. Okay, so we're going to do propane right now, then you're going to do butane, pentane, and hexane for homework.